Are we live? Is it recording? All right.
So.
What's up?
Yeah.
I'm Austin Griffith. I'm here with Etta and Carlos. This is BuidlGuidl Labs, where we deep dive different topics in the Web3 space to get you going and excited and building. Today we're going to talk about scripting. And we've talked about scripting in the Web2 to Web3 kind of intro. But our theory here is that you need to build your own CLI. And of course, like, there's 1,000 different people out there that have built their own Ethereum command line thing, but you need to build your own. And in most cases, like, you shouldn't reinvent the wheel. There's so many different great tools and abstractions that you should use. In this one case, I'm saying you definitely should reinvent the wheel because it's so informative to go through the process of trying to build your own command line system to talk to Ethereum, make transactions, listen to the chain, providers, signers, wallets. We'll get into all that stuff. But today we want to motivate you, the builder, and get you started with the process of building your own Ethereum command line. So let's dive into it, and I'll share a screen here and we can get going. I think we should start from scratch. We started from scratch for the scripting build, and I have here, these are my shitty scripts, which I will share also, but I think we should just start from scratch. We're a decent developer and we want to set up our own scripts. We've gone through the Web2 to Web3 curriculum, and Carlos has already taught us how to create a project, but I want to do that again just to make sure I can, and just to make sure I kind of, like, you know, cover all of our bases. And Carlos, you taught me all this stuff, so if I do something wrong, be sure to shout it out too.
I will do.
All right. So let's see. Let's make a directory. What are we going to call it? Scripts. ETH scripts.
Yeah. BG Labs.
BG
scripts.
Labs.
I don't know.
Scripts. Perfect.
Yeah.
Got it. All right. And we need to. Is it yarn in it? Right? Isn't that kind of how to get it started? Yep. BG Labs scripts. We're just good with all this stuff.
Yeah.
And maybe we'll touch some index.js so we have it. Now, right here, this is the part where if let's actually go do it and have it cause the problem where we need the type modules thing. Let's go kind of like get started with this and then come back to that problem, because we're going to have that problem pretty quickly. But let's open this up in, let's put our shitty scripts over here. Here's our new scripts over here. Oh, this is really zoomed in, but I think we got it. So we need ethers.js, right? And I always just you can definitely just do like a little chat GPT and be like, yo, chat GPT, how do I make an ethers.js script in Node ES6? I'm going to just say import, think you'll get it. That listens for new blocks from a provider, something like that, right? IDK, what we're even going to get here, but let's just get ourselves a script started. Oh, certainly. ChatGPT, just super excited to help us out with our scripts this morning. All right, let's go. We're going to bring in ethers, which means we probably need to yarn install ethers over here, right?
Yep.
Yarn add ethers. Nice, very, very, very small package, very clean. Definitely not like the things I usually write. Let's see, and what does it have us do? See, it has a main function. I'm not even going to do that. I'm going to
maybe you can copy and paste this, and we can check that something is not working, because I think it's going to fail because of the import. And then we can fix that, and maybe we can rewrite with await async, maybe, because it's...
Here it is, yep.
Yes.
Here we go. So copying, pasting this directly from ChatGPT, it's creating an async function, which allows us to do this await, right? Wait, where's the await?
There is no await there.
There's no await here. There should be an await eventually. We will have that.
Yeah.
And then they're calling it over here. So they're creating the function and then invoking it. And what that does is allow you to, if you wrap this, then you can do some awaits inside of here, and then this thing can just trigger it. But when we go to node index and we run it, it says you can't use an import statement outside of a module. This is the trick that I have to do every time that I just learned from Carlos. I have no idea what I'm doing, but I go here and I say type equals module. And that frees everything else up. Then everything else starts working well, right? Then we go back over here. Let's try to do a node index. There we go. Something's happening, but it's telling us that Ropsten doesn't work because Ropsten is old and ChatGPT is technically using content from like a year and a half ago. So that's why that is. But our script is running now, right? So now what we need is to tinker with some providers first. So a provider is basically a node, right? And I think that like we should definitely do a BuidlGuidl deep dive into running your own node. But assuming that you either have your own node or you're going to use somebody else's node, a provider is basically someone who's running their own node like this, but they open it up to RPC calls, and people can make requests to those nodes. So the most famous one is Infura, and there's also Alchemy. But remember, you're building a decentralized app here, and you're relying on a centralized service. So there's always, you should be thinking about what your assumptions are here with these providers. And the best you can do is run your own node if you're setting up your own local scripts, and it's going to be a lot faster when you do that too. But let's tinker with some of these providers. Whoops, let's get out of there. Let's go to, I'm going to grab some of my other ETH scripts because I have a whole bunch of different RPC URLs. So I'll start with that. Can I get rid of this main now? Can I ditch that?
Yeah. One of the things, when you do like the type module thing,
yep,
you are doing the imports are going to work like they are working now. But also what it's doing is that you can do await in here, like in the top level. Because if you don't do that, like you need to wrap everything into like a sync function. But in this case, you can do that, and when we use like the await, it will work.
Awesome. Okay, so I've got a handful of different RPC URLs. This one would talk to my local like hard hat. This one talks to this machine here that I have running. This one talks to the Scaffold ETH RPC, which is another node that's running for Scaffold ETH folks. And then this one is Alchemy, and it's even WebSockets right now. So a lot of different URLs, and you can just go to like Alchemy. Ooh, I don't want to like expose my Alchemy keys, but you can just go to Alchemy and sign in, or go to infura.io and sign in, create an account. You'll set up like what network you want to be on, and then it will basically just give you a connection to that node. But again, like running your own is always the best. So let's go grab my local node here. Yep. This is not an Infura provider though, right? It's like a JSON RPC provider.
Yeah.
Let's see if it just, yes. Yep. And if you're using WebSockets, you'll want a WebSocket provider. And, part of writing your own scripts and learning how to write your own scripts is going to be having to navigate the Ethers documents, the Ethers docs. These are hard for me. I don't know if my brain just works a different way than Rick Moose, who created this, but I have a really hard time with the Ether docs. I only go here if like I can't get ChatGPT or Google or anybody to answer my question correctly. But you can also go here and just look up providers, and you're going to find a lot of information. What I really wish the documentation had is just like a giant cookbook of all these different examples, like every single example I can think of, reading events, writing a Megan thing. Like I wish they were all here, and I don't know, maybe they are, but I just have a hard time finding them. So what I did there is there's an Etherscan provider, but I'm looking for that. There's the Infura provider that we replaced, an Alchemy provider, looking specifically for like this JSON RPC provider. It's not here. Oh, here it is. Here we go. This is the one we're going to use, which is basically like give it a URL and it will connect. Okay, and then the other thing I'm going to do is can I do provider? I think I can do provider dot on, and I can say, oh, there, it's going to do it. Yep, I want block. There we go. It's going to give us a block number. Something like that. Yeah, there we go. And let's get it. Of course, we need a new emoji.
So Austin, like you were saying that like using a provider like is basically connecting to a node, right? Because like there's like no way to query the blockchain like directly, right? Like you need one of these nodes. So for example, for someone who's coming from the Web2 world, like maybe we could see this like a API to access the blockchain, right? Something like that.
Totally. Yeah. And it's not like one central server is the API for the blockchain. The way the blockchain works is, thousands of nodes all communicating peer to peer, and you can go to any one of those nodes and ask them for this information. So it just happens to be that Alchemy and Infura, they run a bunch of nodes and then they provide an API like service to go talk to. But also you can just have your own node running and query it, or a lot of other things. You just have to get to one of these nodes, which is, it used to be just Geth, but now it's a combination of both the execution layer and the consensus layer, which is like Geth and Prism together. That makes one ETH node these days. We'll do a whole episode on spinning up ETH nodes with different, Nethermind versus Geth, Prism versus Lighthouse. We'll get to that stuff later, but assume here that like at first you can just talk to Alchemy, or you can talk to Infura and just get an Infura key and start querying it. It'll just be slower, and you'll want to have your own locally. Actually, the Alchemy WebSockets is like the fastest provider. Even when I have one like locally running here, it's the one that finds the new blocks the soonest. And let's go tinker with that. The reason is Alchemy has a ton of different nodes running in different locations, and they're able to see the transaction sooner and get it to their main service and get it out on a WebSocket. But let's play around with this. Let's see if this even works. Yeah, there we go. So it's actually talking to this node here, and you'll see every time this node kind of like ticks a little bit that our script ticks a little bit too. Let's see. We're waiting for new blocks to happen here.
So in your code, you basically subscribe, like you did like a event subscriber, right? There, you just like subscribe, you instantiate the provider, and then do like a event subscriber to that provider on block, right? So every time that a new block is happening on the blockchain, you will get that line, like line 13 will be triggered.
Exactly. Yep. And I'm just gonna say, I'm gonna change this. I'm gonna do two at once here. I'm gonna set up a local provider, and then I'm gonna set up an Alchemy provider, and this will be, oh man, it needs to be a WebSocket provider. Let's see if I can do that. Yes, thank you.
Autocomplete for the
yes, web. Thank you, autocomplete. And we'll grab this one, and I'm probably exposing some kind of key here, but that will happen. And then we'll say Alchemy provider .on block, and we'll say Alchemy block. Now let's see.
Usually, no, run this. I was going to say that. Is this the same block? Should be the same block, right?
It should be, yeah. We'll see them now. What we're doing is we're watching for them to come in at the same time. Oh man, why? It looks like Alchemy is like ahead of mine a little bit. Look at that. Yeah, mine is coming in way later, and it's probably because I'm HTTP pulling first of all instead of using WebSockets. So there's a little bit of delay there.
Yeah.
But you can see here that if we're watching both chains, we're watching my local chain and we're watching the Alchemy chain. It looks like it comes in a little bit quicker from the Alchemy chain because they detect the new block sooner. It's like it's a short distance for me to my node, but for my node to the rest of the network, it's slower. So it takes a while for my node to see the new network.
Yeah, and also probably like you said, the polling, like you are like polling to your local node, and Alchemy is WebSocket, so it's just like a direct connection. So
here we go. One cool thing that you can do with your local nodes is you can just switch it to WebSockets and it will work. So let's try that. So now we're both on WebSockets. So it's going to be, but it's still, I think Alchemy is going to get here first because Alchemy, it's close.
Now it's pretty close.
Yeah. Let's do a couple blocks here and see how they come through. And this is a cool thing about the merge. Now that we're running on proof of stake, these blocks come every 15 or 12 seconds every time. And unless someone like misses proposing a block, but what we get is a real regular cadence of blocks, which makes the user experience a lot better. Looks like something fell over here. Where's my local node? He's back on. There. He finally got 94. Then he got 95. Wow. And this is what I wanted. This is one of the first steps I wanted to take in terms of writing your own ETH scripts, is playing around with these different providers and understanding the delays and some of the, like, you're going to have rate limiting. If you're trying to make a ton of queries against Alchemy, it's just going to slow you down eventually, because you can't, like say we had to check in on 1,000 different transactions. It's going to be a lot easier for me to talk to my local node about that. Okay, so we have a connection. We're able to talk to our local node with WebSockets. We have a provider. We're listening for new blocks. I think probably the next step is either trying to, let's see, provider, speed, cost.
Maybe you can also like put some of the stuff that you can do with providers. Like once you are connected with a provider, maybe you can, get the balance from someone, or resolve the ENS from someone, something like that.
So you can do local. So we'll await, right?
Yes.
Local provider block number, right? And then if we console.log that. So that's going to do this same thing, sort of. Let's even just like, let's comment this out for a second, right? So it just runs the script and finish. Actually, if it's a WebSocket provider, I think it's going to hold it open. Let's see what happens here. Yes, it gives us our local block, but it holds it open because it's a WebSocket provider. So I'm going to go back to JSON RPC provider for a second. And then it just kind of like runs the script and finishes, right? So we're just asking for the local block. Okay, you said get balance, right?
Or maybe like the resolve name, like a ENS resolve.
Ooh,
like
yes,
you can do like provider.
I don't remember what it is. Is it?
Yeah, it is a resolve name.
Resolve name.
Yes.
Okay, and that would be
like
atg.eth.
Yes. And that's going to give you the address from
we need like a little name tag icon, of course. Let's see what we get here. There we go. So for given atg.eth, it found that this is my address, right? And then maybe we could do my balance after that, right?
Yes. And we are going to get like a ugly number back.
Right. Okay. And this needs to be like a stack of cash, right?
Yes.
When you're writing your own CLI, you have to have a little bit of fun with it and enjoy it. You want to feel like hacker man.
Are important.
Yes. Let's see. Balance. Local provider.
It is get balance.
I think
it's balance. Yeah.
And how? Okay. So let's say you don't know what it is, right? And you can't just ask ChatGPT, because ChatGPT will tell you, right? Get the balance of atg.eth using ethers.js, right? But that thing is going to tell us that. But also you could go here and you could probably search for balance, or maybe even you could Google it.
Yeah, but also
signer. Here.
Like the autocomplete is also like super powerful. When you do like local provider you get like all the function that you can query, and I don't know, get balance is pretty intuitive.
Yep. So look at all the things we can do. Get signer. Ooh, get gas price. What's that going to give us? I kind of want to see that one. Let's do that next. Const gas price equals await local provider get gas price. Yeah. Ooh, a rocket. Why not a gas station? Let's go gas station. Come on. All right, here we go. All right, what's this script going to give us? Okay, now here's where we get those ugly numbers, right? If you've gone through the whole scripting with us, you know that you get weird big numbers, and sometimes you need to, and we'll have two examples here, right? Sometimes you need to just go to number, right? You could do a dot to number. This is even a big one. You don't want to do that here, but let's see. It does work, but
it works because that number is small, but
small enough.
If you do that, sometimes can overflow. Because the reason, can you explain the reason that we need to use big numbers? And it can be,
it's JavaScript's fault, right? JavaScript doesn't use enough bits to represent their numbers as we use basically 256 bits to represent a large number on Ethereum, and JavaScript is probably like a 32-bit or something like that.
But also the reason is not only the JavaScript fault, right? I mean, it's also because on Solidity is like we don't have like floating numbers, right? That's why we need like these big numbers that you need to path with all the zeros, right? You have like this way unit. So that's why JavaScript use that to not overflow. So there is like a ethers utils function. So you can do like ethers. I think it's utils format ether. I think it's format,
Yep.
right?
Format ether. I'm not even letting my autocomplete do it, but there's kind of two functions that you'll use. There's ethers utils format ether.
Yeah, I think it's format.
And there's if you're going the other way around,
parse,
it's
right?
utils.parse ether, right?
Yes.
So in this case, you would put something in like 0.1234, and that would be in ether. And in this, you would put in some big number that is like this object that we have over here, and it's going to take that and turn it into it's going to take it divide by 10 to the 18.
Yes.
Yeah. Okay, so let's go look at that balance now. Let's see what we get. There we go. So you get 0.574, right? Now, if you're at home and you're building your own scripts, you see this, you're probably like, okay, now what I need is the price of ether. And if I can figure out the price of ether, then I can display my balance in dollars. And that's how I get started writing my scripts. Like I said, okay, so now how do I go find the price of ether? And I probably have a bunch of different ones. You could go to Etherscan and get it. Let's see, do I have that? Etherscan could give it to you. You could go to the Uniswap V2 contract for DAI, and you could read it from
that is the fancy way, right? That is the fancy way. Like going to the Uniswap and getting like the DAI, like USD, and so you can get like the
Yeah. Let's see. Is this going to? Yes, this will give us the ETH price. Let's just bring this in, okay? So I'm going to create a library file. So I'm going to create a new folder here called library. We're going real slow with this, but I'm going to create a libs folder. Then I'm going to call it a new file called etherscan.js. And then inside of that, I'm going to bring in etherscan and a dot environment. So I'll have to like sneak an etherscan key in here. But then this will let me load etherscan. So then in my front end, I'll have to import it here. Okay, and then once I have that, then I can run, let's see, go back to that example. There we go. This will give us the price of ETH when we want it. Maybe we do that like here. ETH price. And then eventually we'll use that to multiply down here to get the price. Let's see if this works. Okay, so I need to, I'm going to switch it off for a second. I need to do an env file, and I don't want to leak this specific.
Yes. And you also, I think you also need to install the libraries, right? You need to install the Etherscan API library. And
let me get that. Let me get that in a second. So I need to.
While you're doing that, just a short disclaimer for folks like who are just getting started with scripting is so we actually do cover like all the scripting parts in the Web 2 to Web 3 series as well. Like I think over there we went through like the DAI contract and we got I think we got the price from there. But yeah, this is going to be a different way. But just like disclaimer.
Yeah. Going to the DAI contract is definitely the coolest way to do it, right? Like
yes.
You're basically asking the chain what the chain thinks the current value is of ETH to DAI, and that's like the price on chain. Okay, yes. I think I have now an Etherscan.
And maybe now is also like a good time just to kind of also mention that, for example, now we're using providers, so we can only read stuff from the blockchain. But next we'll be moving on to like how you can actually like also write stuff with signers.
Yes.
Yep. Okay, so Etherscan API, I need to install both. Do I need to install the .dev stuff or the env? This .env.
Yes.
So yarn add .env.
Yep.
Okay, now node index. What do we get? Yes, we get a price of ETH at 1208, right? Okay, now we're moving. Go ahead, Carlos.
Yeah, I was going to say, like, the library, this .env library is a way where you can create these .env files, and you should store your secrets there. I mean, you shouldn't be copy and pasting your private key or your Etherscan API key here on the script itself. So, for example, if you are deploying this to a server, you can have the secrets stored in your server, and it will load from this env file, so you can access, to all the secrets, like the Etherscan API or your private key or the Alchemy API key. So it's always good to have it in a separate file or in a secret file, because if not, if you commit this to GitHub, for example, you will expose all your secrets there, which is something that you don't want to do. Usually.
Right. And we'll get to the burner wallet soon too.
Yes.
So formatted balance looks like that. And then we're going to do formatted balance times price of ETH. And we're going to put a little $ by it. And we're going to, do I have chalk? Oh, I should get chalk going. Another thing, if you're writing cool, there we go. So 190. Oh, how do I do like rounding that? You do precision?
I think it's floor, right? Not floor or
floor,
something.
Round, floor. Yeah. And then how many like decimals I want? Like 2 or something like that. Let's see if that did it. That didn't do it.
No, maybe I think it's
5. I'm just shooting in the air here. No, that's not working.
I think it's I think it's to fix. Yeah, to fix is the fix it. Fix it. Yeah.
Yeah. There we go. I got my Carlos GPT going.
No, but I think it's
math to fixed. No,
it's not math. I think it's just the number and then dot to fixed. So is that the result of that to fixed? You don't need
something along the lines of that.
Yeah, let's see that will work. I think.
Oh, we got decimals. Yes. All right, nice. Let's go down to the penny. Oh, that is looking good. Okay, I'm bringing in chalk. I want to make it green too. Like, yep, we're on a live stream recording all this, and Austin's over here getting chalk involved so he can turn the things into a little bit nicer color. Come on. Yarn, add chalk. There we go. But I'm serious, you got to enjoy the process of making your CLI too. Like part of this is about enjoying it. Painting pretty little trees and whatnot. There we go. All the way over to here. Now we've got our balance in nice green dollars. Oops, node index. Ooh, yeah.
Look at that.
190. Doesn't that look good? All right, and what's the gas price? So we need to format Ether on gas too, right? I almost want to make a function that does like all the formatting and turning it into dollars. So I just pass in some ETH value and it gives me dollars back. Let's see what this looks like. What's the gas price right now? Yeah, see, that's so hard to, and that'll be multiplied by, I don't know. I was just tinkering around with that. We don't even really need the gas price right now. We're going to let the API or the provider basically give us the gas mostly.
Yeah, so I think like next, like Eda was saying, we are using only providers and just like reading data from the blockchain. But what if we want to write something? What if we want to send a transaction?
So a lot of times let's see, generate a new wallet with Ethers.js, right? Something along the lines of that. But I can also find wallet here. While that thing is looking, we can search wallet and see how this works. So you can create a new Ethers wallet by passing in the private key. And you can probably generate a new wallet. Yep, create random is just going to give you a new wallet every time. So we could do something like, let's close everything off for a little bit, give ourselves some tinkering space up here. Oops. Let's do something like const wallet equals new Ethers wallet. Oh, what? With all 0. Oh, man, I like that. That's the private key it's going to use. Okay, let's go with it. So this is a bad idea here, but it's basically going to use that private key that's all 0s and then a 1. What that is going to give us is going to be a wallet that does have an address, and if we actually go look at it on Etherscan, that wallet has been used to make transactions. And if someone accidentally YOLOs money to this, like this person put in 0.09, it immediately gets swept by someone running a bot. And you at home building your test suite, you should be able to run that bot. You should, if you wanted, you could create this wallet and you could watch for new blocks and you could watch for a balance coming to this address, and you could sweep it as quick as you could by putting just the right amount of gas and stealing this money to your account if you wanted. We should be empowering you to build cool stuff like that by making these cool scripts. So we have a wallet. I don't want to use that one though. I want to generate.
Maybe you can just like throw like some random numbers in there. I don't know.
Oh, I see. Just like make my own entropy here. Something like that, right? That's going to give us a new wallet. I bet no one has ever used this one on Etherscan. Yep. Okay. So we got, it's still not great, right? I just added those two little things. There's not a lot of entropy there, but technically that's a new wallet.
Yeah, and this is just like a test. Like if not, we should also copy this private key also to the M file. So we would use like the process.m.private key or whatever here. But in this case, we are just like tinkering. So yeah.
I have a library to do this. I want to do one more thing. I want to do this create random too. Wallet.create random, and then now watch this.
I think you don't need the new, I think, or
is there a new?
I think it's the same, right?
Oh wow, it was happy with that no matter what. So check this out. What we have here is it's creating an address. What if we try to create addresses as fast as we can and check the balance of them, and just try to create addresses over and over again and see if we can find an address with a balance in it?
I'm sure that you are not the first person trying that.
Yes, it would take us until the heat death of the universe to find an account with money in it. But let's just go through the motions of checking that real quick, right? So we create a wallet, and then we get the balance of the wallet dot address, and then we say if balance. Let's just console log the balance for now. So basically what we would end up doing is we would check to see, let's go ahead and console log the wallet address too.
Or you can do like a loop even, right?
Right, yes. Here we go. Come on, just write it for me. Thank you. So we're going to create 10 accounts and we're going to check against, hopefully against our local node. So it's only like going this far to ask this. If you were going to Infura and you were trying to loop, this would be very, very slow. But let's see here. There we go. We created 10 addresses and all of them have 0 in them. Can you believe it? Could you believe it? Okay, let's do 1,000. And it's always going to be 0, right? And you could sit here until the heat death of the universe with all the compute power you have with many, many nodes, checking them, and you're never going to find an account with any value in it. And if you do, it's because some knucklehead did what we were doing earlier and have an insecure private key. But these are completely random numbers. But this is a fun practice. You should do this just once as a developer getting into learning scripting on Ethereum, just to prove to yourself that there is no way you're going to find some random account with $1 million in it. But this is a good practice. Now we want to use the wallet to make a transaction, right? That's our next goal here. Okay, so actually, I'm gonna bring in a different wallet library just to kind of show off being able to build a little bit better scripts. I have this library called Burner, and let me just copy that. And this is just going to create a Burner wallet for me. So it does all the things that we were talking about here, where it generates it creates a random wallet, but I have it appending into the env file the private key. So this will handle all the env stuff for you. You don't even have to go to the env file and put the stuff in. It's going to create a wallet and put it in the env file, and then from now on it'll load that file automatically for you. And then I have this open burner wallet function that actually creates a burner wallet with that private key. And I'll show both of those off real quick.
This is good stuff, Austin. I mean, I love that script.
Yeah, it's a good one. Yeah. Okay, and so let's just go ahead and do this. What is it? Load burner wallet thing. See what this does. I think I may need to await that. Okay, now let's do a node index. And there, it looks like it just generates a wallet and gives it to us. But now we have the same wallet every time. And now that private key is already in the .env file. We didn't have to copy and paste the private key ever. It just generated it, put it in the env file. And if I do a get status here, do we have the env file around? We need to make sure, right, that we ignore that env file. You almost want to like probably write your .getignore ahead of time. That right? And put in .env and node modules, right? There's probably a better way to do this. What's the best way to have your getignore working correctly?
I don't know.
This isn't a Git repository at all.
Yeah, I mean, maybe you can do like a git init if you want. Like, you can do like a git init. Yeah, and now you can,
There we go. And let's see, what are we ignoring? Do we need to ignore the yarn.lock, or do you leave that? Basically, these are all good. It's already ignoring that env file because I have it in the getignore. But you want to be super, super, super hella careful right here and make sure that env file is not getting committed to GitHub. I've seen so many developers lose $100 here and there because they put just enough money for gas and it immediately gets swept because they had their private key or their mnemonic in a file that got committed to GitHub. Okay, so now we have a burner wallet. And what I can do is I could do, I think I can just do wallet here. Const wallet equals await. Okay, now this is going to expose my private key just for a second, but I'm going to call this open burner wallet thing. So if I do node index now, it's actually going to open. There was the private key for a second, but here is my burner wallet now. So now I have this like nice wallet that represents a local like account, and I can do things on that account on any different network. Let's jump to localhost. Should we bring up? I was thinking of bringing up a scaffold ETH build. So we have. Just do a yarn chain here. And just have a local chain that we can play on. There we go. So I just brought up scaffold ETH and I fired up a yarn chain. So now we can do localhost instead of my local node. And we don't need this. And let's go ahead and get the balance of our wallet while we're here. Wallet.address, local provider. Let's do this. What do we get? Okay, we're getting 0. But now, let's see. If I put this guy on localhost, a nice little button to grab funds from the faucet. Isn't that nice? Now I've got $12 and I'm hitting my local chain. Now I've got a balance. All right, cool. So now we have a burner. We're talking to a local node. We can kind of like orchestrate some different transactions locally, or even, dude, can we do a yarn fork? You could even do a fork of mainnet, but we'll have $0. Oh wait, can we do this on a fork of mainnet? Oh wow, okay, that's really cool. So now we have money and we're on a fork of mainnet, so we could talk to like mainnet contracts. Like technically I could orchestrate like a swap right now or some kind of transaction. Let's get it going. Okay, so let's send money from one wallet to another. Go ahead, Carlos.
No, I was going to say that, like maybe for starters, like we can do like the first signer transaction. It can be sending some money from your wallet to another wallet, right?
Yeah.
ChatGPT.
Right, I'm just like getting all this fired up so I have stuff that I can steal, but I can also go look here, right? We want to send transaction.
Yeah, first we will have to init our signer from the wallet.
Okay, right. Okay. So far we've talked about providers and wallets, but we haven't talked about signers yet, right? The signers are, it's a combination of a wallet and a provider. Is that right? Let's see. I mean, it's basically an account. A signer is basically a wallet, but maybe you attach a signer to a provider, and that's what we're going to do. So we're going to have our const signer equals our wallet. Oh, it was just right there. Our wallet dot connect, and then our provider. And so now our signer is connected to the provider with the wallet. And I think we're close to being able to make a transaction. But we don't want to sign a message. We want to send a transaction, right?
Yes.
Or do we sign the transaction or just send the transaction?
Like if you want to send money, we can just like
yeah. Can we just do signer.send transaction and just have like a to from kind of thing here?
Yep. Yeah, I don't know if that's going to work.
We're going to find out. Okay, and we'll const result equals await this. And then console log the result. Let's see what happens here. Okay, it doesn't like ENS because we're not on, since we're on a mainnet fork, it doesn't like that. So let's actually just create another burner wallet. Let's see. Let me go here and make a new one of those. Oh gosh, make a new one of those. There we go. New private tab. Go to Punk Wallet. Nope. Go to Punk Wallet. .io. Go to localhost. There we go. So here is this person. We got old Blondie there. Let's send some money to old Blondie from this dude over here. Here's the address. Let's see what happens. Oh, we got a transaction, right? There it is. So that is technically a transaction on mainnet, but it's not actually going to mainnet. It's just going to our fork of mainnet. But if we look over here, shouldn't they have some money? Maybe it's not getting...
Can you check the terminal? Yeah, and see if the transaction is it? Oh, it's there, right? The transaction is there.
Yep, it's there. 0.0001 ETH. Maybe I didn't send enough. Let's do that. Let's make another transaction. Where am I sending the money to? Is it leaving this address? Let's see. It should be leaving this address here and going to that address. What are we doing wrong here? Let's see. Maybe we just should have this on localhost or on some test net or something.
Can you check on the terminal when you are where you are running
over
the node?
Here, right?
Yeah, and see if the address are from and to addresses are.
Uh-oh, ran out of money. Okay, yeah. Let's get ourselves like way more funds. Okay, now we have plenty. And if we want to send 0.01, there we go.
Yes,
so the to address is D3E99. I'm not sure why it's not sending to this person. I'm not sure what I'm doing wrong here. Maybe we should move to a public network and start talking to some contract or something like that, right? Okay. I'm not sure why this transaction is failing.
So is what is the terminal saying? Like the chain?
Here. Yeah, it's saying that
a bit bigger.
From to, yep. It's definitely saying that the transaction is happening. 0.00 ETH from this dude to that other one that I already closed.
I don't know. Can you try with the with no fork, just with the yarn chain, and see if it works with the hard hat node?
Yeah, probably.
I don't know.
We're probably like a little too far into the weeds on this one. I probably shouldn't have gone this far. Sorry, we are so far in the weeds on this one. Punk Wallet. .io. Have this guy's address. Can I just send this guy $5? Like, does this work? Oh, that's Ethereum. I need to be localhost. Yeah, maybe something's weird with why it's when it's on a fork, right?
Yeah, maybe you can switch to.
Yep. Let's just do yarn chain. Let's get a normal chain going. Okay. Let's reload this. This guy's back to 0. Now he has funds from the faucet. Reload this. This guy's back to 0. Send $1 from this person to this person. Does it show up over here? What is happening?
Yeah, that's weird.
Okay, if I just copy this guy's address and just put it into the faucet. I'm going crazy. I don't know.
Why are you not getting like the graph funds from the faucet on the right side? You are not getting that, right?
Yeah.
On the right side.
Yeah, usually, this guy's not seeing it.
Usually, you get like the like the faucet hint.
Oh, I bet there's something weird with Brave talking to the local node. Look, let's do like Safari or something weird like that. Okay, and let's get a new wallet. Okay, and now let's see if we can put this person on localhost, send this person some funds.
I mean, you can also like spin like a scaffold ETH.
Yeah.
Right.
Yeah, we can go back to the scaffold ETH. Something.
Yeah, I think it will be like failing something.
I don't know if something's wrong with the Punk wallet or what. Yeah, this has just been a bad demo. I'm sorry for you at home who has gone down this. Okay, let's get back to finishing up our scripts here. We are way too far into this. Okay, so we do have. Let's see. We've created a signer with our burner wallet, and we've created a transaction that should send some money to our wallet. Should we do this on Goerli or something where we just are on a network and we're not so, or mainnet or something? Let's see. I need a Goerli. Yeah. This would be mainnet. I kind of don't want to do it on mainnet because then it's, I mean, we technically could send some money, but I don't know if we want to do that on a, let's see. Okay, let's go to ChatGPT. Connect to Goerli from Ethers.js. Let's see if it just gives us an Infura provider or something I can just copy and paste. Yeah, it's going to give us an Infura provider. Sure. Let's go.
It's really fast.
All right, let's see if this works. Just grab, we'll use there, instead of local provider, we're just going to have a Goerli provider. I don't want to name it Goerli provider. We'll create a new wallet. We'll check our balance. And we're going to have to get some funds to our account first. But let's get this far. Okay, we have $0 on Goerli, which is good. Let's console log our wallet. So we have the address. Make sure the address is the same every time. All right, now let's send some. Is that this guy, 32? Okay, let me send some Goerli to this guy. Please, Punk wallet, please work. Pull up my Punk wallet on my phone and put it on Goerli. And YOLO some funds to this dude.
Yeah, I think it's going to work. I think it was something related with the local host.
Probably. Okay, got some funds sending here. Hopefully we get some Goerli. Takes about 15 seconds, right? It's going to be about a 15-second. There it goes through. There we go. Okay, so we have $100 on Goerli. Let's make sure our script agrees. Yes, we have money. Okay, so we have money on Goerli. We have a balance. Now we set up a signer by connecting our wallet to the provider. And then we want to send some money. Okay, now let's go create another wallet here, Punk wallet. Let's go to this guy on Goerli. Okay, this guy's empty. Let's grab his address, put it in here. Now, hopefully, we will send 0.1 ETH. We have 0.08. and we have 0 over here. Hopefully this will create a transaction on Goerli. Let's see, do you do the await thing? I think there's a result.
Yeah, it depends. Like if you want to get like the instant like transaction information, you can do that. But if you do the wait, it will wait until the transaction is mined.
Right, so this one is going to give us a transaction, and this is going to wait till the transaction's mined, right? But I'm going to do both of those so we kind of see it happen.
Maybe you can, okay, yeah. I was going to say that you can have like a message after the wait, but...
Right, so at this point, the transaction is in the mempool, but it's not mined yet. We're waiting for it to mine. And then we have this guy, and we have this guy. I think this is going to work. Let's see. Oh, yeah. Transaction just went through. Oh, then this dude has money. Okay, so something was weird with localhost, right? I don't know what was going on there. Okay, so you've got your provider, which is your connection to some node on the network, and it can be your own machine, it can be Infura, it could be Alchemy. You can talk to it either over WebSockets or polling with HTTPS. Then you have your wallet, which consists of either a mnemonic or a private key. You usually want that to be in your .env file, and you load that up. You can get your balance from the provider. And then to make a transaction, you have to create that signer, right? That signer is important for making transactions. And you basically take your wallet and you connect it to the provider. And then from there, you can just send transactions here to value. Okay. So now let's just do like a speed run through some other scripts that you can run. I feel like we're here way too long. So let me just do like a quick speed run of things that like you at home as the builder should go explore and build with your own local CLI. So I have a handful of things here that I have built. One is compiling. This is super weird. So if you want to compile your own contract, it looks something like this. You'll bring in SolC. I'm just going to copy and paste this probably and make a new compile file over here. So here is how you would compile your own smart contract to bytecode using SolC. So we'll yarn add SolC. And then let's just node compile and see what we get. Oh, what? Is there no output? Let's see. There it is. Okay, so compiling our contract, we have the contract hello world. So basically I'm passing this big object into SolC, and it contains the smart contract, and then it's going to give us back the contract, the bytecode, and the ABI. And that's what we have over here. You've got your bytecode. Let's change this just a little bit. Let's maybe add a... is it going to know how to do this? Yeah, that's right. There we go. So now let's recompile that, and you'll see our bytecode got a little bit bigger after we added that new function. Okay, so now let's deploy this contract to Goerli, right? So let me go grab my deploy script. And what's that going to do? It brings in our burner wallet, connects to an RPC, creates a provider. But here, you need your bytecode and your ABI and a factory. And then with that, so it's the factory is what we're using here. And this is from Ethers.js. You'll just have to look up the docs. But you basically set up a factory, pass in the ABI and bytecode, and you set up your signer here, right? We're doing wallet, connect, provider, and that creates that signer. And then your factory can deploy, and I'm deploying with some argument there. So that's deploying. Events are probably something that you're probably going to want to mess with. You want to go out to a contract and read events from that contract. So you create your provider, and then you do provider on block. That's just listening for the block. It's a filter. So you were talking about an event listener earlier, Carlos, or I don't remember what it's called, but we were doing provider.on block, but in this case, we put in our own filter where we put the address and then some topic for the event. And if we pass that into the provider, then every time someone calls transfer on this contract, we see that event pop up here, and we can follow these events. So this would be if you were building some kind of like event indexer. You would be watching for new events on your contract. You would load them into memory and then probably have them on some web server. And then your front end is kind of querying that web server instead of looking everything up from the chain. Pending transactions, you can do provider.onPending, and this is going to watch the mempool. This is really cool because you can see new transactions as they're coming out before they get mined into a block. This is if you're like writing some kind of front running script, or you're watching the mempool getting into, I don't know, the mempool is a dark forest, but you can get into it. Let's see. A lot of these are just like scripts I have for fun. What else would you say is like a good 4-byte directory? So like a lot of scripts I write are just like helpers where they take a function signature and they turn it into something that looks prettier. Or ENS, like we did it earlier. I just have like a quick wrapper around ENS that does like a try catch because ENS fails a lot. So yeah, just little scripts that you'll have that can help you kind of just get quicker and get your scripts together and get like your own toolkit built together. We kind of went on like a long rabbit hole of the Punk Wallet stuff. Sorry about that. But you at home as a developer, you should build your own script library. Even if it means reinventing the wheel, it's good for you to get in here and really get in the weeds with how the providers, the signers, and the wallets work. There's the mechanics between asking providers for information, and then also just like all the little gotchas with creating your own script to send something, right? We had to format ethers, we had to parse ethers. All of this stuff will help you to write your own apps and stuff with Scaffold ETH later. You're going to need all this same JS, but you can do it here in a script without all the React around it, just to learn more. Woo-wee. Woo-wee. You guys asleep over there? Are we still awake? Everybody still here?
High energy.
High energy. Bring it in.
Yeah.
All right. Yep.
I was going to say that the only thing that I think we didn't mention is when we declare like the signer, maybe try to do some interaction with an existing contract, because we only send like some ETH over. So you can learn how to instantiate like a contract, with the ABI, and you can call methods from that contract with the signer. I think we didn't mention that. So I think that's also like
I kind of like showed it off there for a second, but we didn't like fully get into it. I could do like a quick one real quick. Let's see if I go to this.
Are you sharing your screen right now, Austin?
Yes, I will. Just a second. Yep.
Okay,
sorry.
Okay.
I wanted to bring in, well, let's see what's a good contract on mainnet, right? Like what, here, let me just share my screen. And then let's jump into it.
Maybe you can like mint like a Lugi or something. I don't know.
Yeah. Okay. Let's see. Lugis.io, right? Yeah. Okay. So the smart contract is here, and if you don't know about ABI Ninja, you should go to ABI Ninja, paste it in, and load it up, and you get this nice view. So what do we want to do? Should we just like get the? Let's just read something first, right? So if we go to this contract, you're going to find this a lot, right? Contract in Etherscan. What you can do is you can grab that ABI. Let's go back to our node script. So we've got our signer getting created. Let's just comment the rest of this out. Okay, and what we want is this ABI. So we have a const ABI equals that, and a const address equals this. And there we go. Oop, that's got to be around these, right? Okay, so now we need to instantiate the contract object, right? And I think, let's see, do I have an example of that? I think I have one over here. Nope.
If not, you can always go to the Ethers documentation that you like.
Oh, I know, I could. I definitely could go to the Ethers documentation.
I think you can do like is new ethers.contract. You can do that if you want.
All right, let's get that started. Okay, so we're going to do const contract equals new ethers
contract,
and it's just contract like that. Oh, there we go. Address ABI signer, right? There we go. Okay, let's just console log that contract, see what it is. Ooh, I like that. You're going to give me an emoji? I'm going to take it. Let's see, node Oh, we don't want node compile. We want node index. There we go. So we got our wallet. This is what our balance. There's our contract. Okay, so it does say that we do have. Oh, that's just contract address. I want to see the whole object. Oh yeah. Okay. So big old object of different things that you can call. Let's just call the name. Let's get the name out of here, right? Contract.name, and we're going to await that. And we'll say contract name. Now, hopefully this will say loogies, right? Let's see. Oh no, what did I do? Let's see. Weird. The address is the address right? This is on mainnet. Oh, we're talking to Gorley still, aren't we? Get out of here.
No, to localhost.
Oh, yeah. We want this one, right? Let's do this, and let's do
like mainnet provider or local provider, yeah.
Yep, and then we'll have to replace the Gorley provider. Okay, let's try that. Yeah, loogies. Okay, so now we're able to read from the contract now. So if we want to write to the contract, that's gonna be tough. Let's see what kind of.
Maybe we can check the price, right? First.
Oh, we would need to check the. Let's just do like an approve or something. Oh, but then I would need my own token. We would need to like fork it. There's a lot that has to happen here.
Or maybe you can check the mint price and then send some money to the.
Yeah. Okay, so why isn't the price? Oh, the price is probably.
It's not loading for some reason.
It's not loading. I don't know what's up there.
Can you refresh maybe?
Yeah.
It's like the provider is not working.
There we go. Total supply. There isn't a price though.
Yeah, maybe we can check the mint function and see,
Let's just say we're trying to call the mint function, right? We're going to do one of these mints right here, which actually it's going to fail. But let's just go through the motions of it, and then we'll call it a day after that. Let's just get close enough to call it. Okay, so we would have our signer, but it's not the signer, right? It's the contract. So we would call
contract.mint. Yeah.
Result, and we would await contract.mint item, I think is what it was called. Let's see. Let's go make sure we get that exactly. Contract.mint item, and I think we just call it, right? It's going to fail.
Yeah.
Let's see what it does, though.
Yeah, it's like a promise. Did you do like the await in there?
I think the await's there.
Oh, but it's reverted, yeah?
Yeah. It's going to revert because of whatever the unpredictable gas limit. Yeah. So if we had that correct, it would basically give you a transaction object back, and you would do the whole like, can you wait thing, like the same wait that we did on that transaction up here.
Because I think like inside mint item, you need to put like an object with some value on it, right? Because you need to send some value.
Oh, yes. Yep. Okay. Let's say we were going to send some money here. You would say value, and then you do ethers, utils, parse ethers, 0.01, something along those lines. It still will fail for us because we don't have the money now.
Yeah.
I'm going to say we don't have the value. But this is how you would go about calling a function on a contract. And then there was the events. I think I showed that off just for a second, but let's show that again. It's a little bit different. If you want to listen for events, you set up this filter with your function signature here and the address of the contract, and you just watch for those events. So that's all around. Yep, go ahead.
I was going to say that you can combine this. For example, you could, in your script, you could listen to some events. For example, when someone mint an NFT, right? And you can listen and say, okay, when the minting reach like 1,000 mints, then I'm going to mint the 1001, for example. Right? So you will put this minting logic inside the listener and do like your own logic in there. I don't know. You can just get like creative about the stuff and just follow your curiosity, I guess.
Exactly. And if we wanted to do something, let's just do this real quick. I want to do local provider dot on pending. I want to show the mempool real quick. Oh, this is ugly. This is some ugly looking code. But now that I do that, what happens when I run this? Ooh. Let's go ahead and
you can comment
/ all this stuff. Yeah. Here we go. Look at all these pending transactions. Okay, so let's say you wanted to front run an NFT mint, not get 1001, but as soon as the person puts in the transaction for number 1000, you want to put in a transaction with a little bit higher gas than theirs. This is what you would do. You would basically set up, you would set up your provider, you'd set up your wallet, and then you would sit here and you would listen to pending transactions, and you'd look up each one of these transactions and see if it's going to the specific contract you want. And if you find a transaction that you want to attack or front run, then you would then create a transaction like we did with the signer. That's all the same stuff, calling mint on this thing, but your gas price, you would be very surgical about your gas price, and you would set it up a little bit higher than whatever this transaction's gas price is. And they would put their transaction in the mempool, and then you'd put another one in the mempool right next to theirs with a little bit higher gas, and you would get the NFT, and they wouldn't, and they would be like, what the heck happened? And it's because you are a front runner, because you are a scripter, because you watched our sweet scripting show that went way too long and had a punk wallet disaster. But thank you all for coming along on this journey. Even Etta and Carlos, I'm glad you guys are still awake. You're still here. Got the coffee flowing. It's time for Christmas break though now. I think we're done with BuidlGuidl Labs until after the holidays.
Yes.
Awesome.
Short break time.
Short break. Yep. All right. Thanks y'all for being here. Sorry for the punk wallet disaster. Go, you at home, go build some scripts. Go build your own CLI. I know everybody else has done it. Do it yourself, because you really need to get into the weeds with providers, signers, wallets, all this weird stuff with two format ether and parse ether, different pending events, different ways to hold your wallet and your environment stuff, all these different APIs like CoinMarketCap and EtherScan and all these other ones. So much to learn. Go learn it. Any closing remarks?
I think
all right.
Yeah.
Awesome. Hearts. Thank you.
See you.